Hello teacher, today I will talk about computer network in topic application layer 2 in chapter 2 and I am Kanapol Uthai Sombonsuk. Student number is 66360641. For the outline, have a introduction, current server program, standard application. In figure 2.1, we have logical connection at the application layer. In this picture, you will see about sky research and scientific books, and application of each is connection. And you can see on the left side have a symbol to describe this picture. For picture 2.2, have an example of current server program. We have each line connect to router and then connect to center, that is internet. And this is how to connect. You can see this one on the right side is a server, and on the notebook is a client. So that is a client server program. Client server program. In this program, communication at the application layer is between two running application program called process. A client is a server. A client is a running program that initializes the communication by setting a request. A server is another application program that waits for a request from a client. In figure 2.6 is a use of socket in process to process communication. We have two sides of pocket, but the left side is current process and the right side is server process. Current process send a request to socket and then current process socket link or connection to server process socket and then send the request to server process. And you can see the symbol down arrow. Server process respond back to socket and then connection to current process. Standard current server application. During the lifetime of the internet, several application programs have been developed. We do not have to redefine them, but we need to understand what they do. So each application, we also need to know the option available to us. The study of this application can help us to create customized application in the future. World Wide Web and HTTP. In this section, we first introduce the World Wide Web, abbreviated World Wide Web or Web. We then discuss the Hypertext Transfer Protocol, or we know about HTTP, the most common client server application program used in relation to the web. About electronic mail or email allow users to exchange email message. The nature of this application, however, is different from other applications discussed so far. In an application such as HTTP or FTP, the server program is running all the time, waiting for a request from a client. When the request arrives, the server provides the service. In the case of electronic mail, the situation is different. First, email is Consider it a one-way transaction. When Alice sends an email to Bob, she may expect a response, but this is not a mandate. Bob may not or may respond. If he does respond, it is another one-way transaction. Second, it is neither visual nor logical. For Bob to run a server program and wait until someone sends an email to him, Bob may turn off his computer when he's not using it. This means that the idea of client/server programming should be implemented in another way, using some intermediate computer, that means server. Another outline is architect, use agent, user agent, have a sending mail, receiving mail, address, mailing list or group list, and MIME header, web-based mail, case 1 and case 2, and the last is email security. Message transfer agent, SMTP, command and response, mail transfer phase, mail access agent, POP and IMAP. We have POP3 and IMAP4. In this picture 2.19, common scenario. On the top, the electronic mail system needs to UAS two pair of MGAS client and server and pair of MAAS client and server. You can see the client connect by LAN or WAN to MAA server, and also the website client Alice connect to server MCA server by WAN or LAN. Two types of UA common driven GUI based Outlook. The server is mail server also, and MCA client and MGA server is connect by internet. And you can see this one. UA is user agent, MTA is message transfer agent, MAA is message access agent. And this is how to connect step by step. This is the architect of email. Format of an email. Sending email and receiving. You can see each type, each side. The left side is a postal mail and the right side is a electronic mail. For the postal mail, have the detail different of electronic mail. For post mail, we have a address, have a subject or a topic, to someone and from someone. But for electronic mail, we have envelope, have header, have body, and header and body is a message for someone. Email address, local part and domain name, the name of a special file, and mail server or exchange the name of organization. Mailing list or group list and allies to represent several different email address. You can see on the picture another different address send message to primary email inbox for someone. And in figure 2.72, protocol used in electronic mail. About the protocol, command and response. SMTP use command and response to transfer message between an MTA client and MTA server. You can see have a push protocol and pull protocol. In the one is MTA SMTP protocol. 2 is the same thing, and 3 is different. 3 use MAA, POP or IMAP protocol. 3 client server application 1, 2, 3. You can see on the picture. Simple mail transfer protocol, post office protocol version 3, internet mail access protocol version 4. For this picture, the table is SMTP command. Commands are sent from the client to the server. You can see keyword, agreements, description. About keyword, hello, sender hostname, identify itself, mail form, sender of the message, identify the sender of the message. RCPT2 intent recipient, identify the recipient of the message. Data, body of email, send the actual email. Quite the description is terminate the message. Rest about of current mail transaction. Vary name of recipient. Verify the address of the recipient. Noob is check the status of the recipient. Turn switch the sender and the recipient. EXPN mailing list asks to represent recipient to expand the mailing list. Help command name asks the recipient to sending information about the command sent as the agreement. And send form is intent recipient. Specify that the email be derived only the terminal of the recipient and not to the mailbox. SMOL form intended recipient. Specify that the mail be derived or left to the terminal or the mailbox of the recipient. SMAL form intend recipient. Specify that the mail be derived to terminal and the mailbox of the recipient. Before is SMTP command. Next is XMTP response. Response sent from server to the client. A response is a 3-digit code that may be followed by additional lecture information. You can see The topic is code and description. We have three groups: positive completion reply, positive intermediate reply, and transient negative completion reply. 211 is system status or help reply. 214 is help message. 220 is service ready. 221 is service crossing transmission channel. 250 is request command complete. 251 is user not local, the message will be forwarded. And in another group is 354 is a start mail input, and another is 421 is service not available. 450 is mailbox not available. 451 is command abort logical error, local alert. 4.2 is command abort insufficient storage. And next is also the same but another group: permanent negative completion repay. 500 is syntax error, unrecognized command. 501 is syntax error in parent or argument. 502 is command or command not implement. 503 is bad sequence of command. 504 is command temporality not implement. 550 is command is not execute, mailbox available. 551 is user not local. 552 is request action abort, exit storage location. 553 is request action not taken, mailbox name not arrow. 554 is transaction fail. And under the table you can see summarize of all of this. Positive completion repay is this repay refers to successfully completion of section. Positive intermediate reply. This reply refers to acceptance of command which we are given, but request action is begin held in state of suspension and also pending receipt of further information. Contrast negative completion reply is this reply refers to that command was not accepted and request action did not occur. The other condition is temporarily in that case, and also action may be request again. Permanent negative completion reply. This reply refers that command was not accepted and request action did not occur. For example, 2.13, to show the 3 mail transfer paths, we show all of the steps described above using the information depicted in picture 2.23. In the picture, we have separated the message related to the envelope, header, the body, and in the data transfer section. Note that the steps in this picture are repeated 2 times in each email transfer. One from the email sender to the local mail server and once from the local mail server to the remote mail server. The local mail server, after receiving the whole email message, may spool it and send it to the remote mail. server at another time. For picture 2.23, example 2.13, mail transfer phase. After the client has made a TCP connection to the well-known port 25, the SMPT server starts the connection phase. Connection establishment 3, data transfer 8, connection termination 2. We have two sides again, SMPT client and SMPT server. You can see how it responds and how to request about between client and server. The server says 220 service ready, and the client responds hello some.com, and then server sent to 50 okay. This is connection establishment, and another half a envelope header, then separated by blank line, and the last is body. All of this is data transfer. Then finally quite the connection termination. For picture 2.24, POP3. The client opened a connection on TCP 110. The right side is client. Client send username to POP server. POP server send okay back, and then send again like this one. Finally, for the left side, POP3 is difficult in several ways. MP8P4 is more powerful and more complex. And the right side, POP3 has two modes: delete from the mailbox, permanent computer keep remain in the mailbox laptop. All of this is message approved. For picture 2.25 is MIME. Email can send message only in NVT 7-bit ASCII format. English only can't send melody file or video or audio data. And this is 4-bit NVT ASCII. You can see this client send to email system and email system send to Bob. Multiple port internet mail extension MIME is a supplementary protocol that allows non-ASCII data to be sent touch email. For picture 2.26 MIME header, you can see detail of this header. To define the transformation parameter, have for email header and then email body. Content describe define whether the body is image, audio, or video. For table 2.8, data type and subtype in MIME, we have topic is type, subtype, and description. About type, we have text, subtype, plain, description, and format. And about subtype HTML. HTML format C, appendix C. And you can see another on the table. Multiplied message, image, video, audio, application in each different subtype and description. Table 2.9 Method for content transfer encoding. Define the method. Use the encode the message into 0 second and 1 second for transport. We have type and description. For 7-bit AVTA ACII character with each line less than 100 character. 8-bit non-ASCII character with each line less than 1000 character. Sorry for previous. Is a 1000 character. Binary non-ASCII character with unlimited length line. Base 64 6-bit block of data encoded into 8-bit ASCII character. And the last is code printable non-ASCII character encoded as an equal sign plus an ASCII code. For picture 2.27 base 64 conversion, we have binary code and is a non-ASCII data. It's combined and split. Then you will get for a 6-bit chunk. And then beer base 64 converter, and we will get 4 character at finally, and this is ASCII data. In this table 2.10 base 64 converting table, you can see the value of character. Each character will have the different value. You can see A is 0, B is 1. Continue to the last. From big alphabet to small alphabet, and then to 0, 1, 2, 3, 4, and then have a and then 2 the symbol. Picture 2.28 chord printable. Base 64 is a redundant encoding stream overhead of 25%. If the data consists mostly of ASCII character with a small non-ASCII portion, we can use chord printable encoding. And you can see it's a mixed ASCII and non-ASCII data. You can see the binary code to be a symbol or character, and then it's chord printable. We will get ASCII data. For Pixel 2.29 is a web-based email case 1 and case 2. For case 1 is only receiver use HTTP. For case 2 is both sender and receiver use HTTP. You can see how different the client on Case 1. Alice use SMTP client, but for the case 2, Alice, the client use HTTP client. For domain name system DNS, to identify an entity, TCP/IP protocol use the IP address, which uniquely identify the connection of a host to the internet. However, people prefer to use name instead of numeric address. Therefore, the internet needs to have a directory system that can map a name to an address. This is analogous to the telephone network. A telephone network is designed to use telephone numbers, not names. People can either keep a private file to map a name to the corresponding telephone number, or can call the telephone directly to do so. Then the outline is a namespace, domain namespace, domain, distribution of namespace, zone, and root server, DNS in the internet, genetic domain, currency domain, resolution, recursive resolution, iterative resolution, caching, and resource record DNS message, encapsulation, register DDNS, security of DNS. For picture 2.35 purpose of DNS, TCP/IP use a DNS client and DNS server to map a name to an address. The TCP/IP should need the IP address of the file transfer server to make the connection. The following 6 steps map the host name to an IP address. This for 1 step is host name, 2 step is application layer, the 3 is query, 4 is response, 5 is IP address, 6 is application layer to network layer. We need at least 2 connections in this case. The first is for mapping the name to an IP address. The second is for transferring file. Picture 2.36 domain namespace. Namespace, a namespace that maps each address to a unique name, can be organized into ways. But a name is assigned to an address cannot be used in a large system. Hierarchical. Each name is made of several parts. No ambiguity and duplication. You can see the top is root, under level is top level node, and you can see another node. To have hierarchical namespace, a domain namespace was designed. Each node has a label 63 characters. The uniqueness of the domain name. The root string is a new string, empty string. For picture 2.37 is a domain name and labels. Each node in the tree has a domain name. A full domain name is a sequence of labels separated by dot. FQDN is a full qualified domain name. A label is determined by a null string. PQDN partially qualified domain name. A label is not terminated by a null string at the same type as the client. Let hop upload, and then another under label is node. Label, and label. A computer dot b dev to dot topuniversity dot edu is a domain name. You can see the URL. Then pager 2.38 domain. You can see the root. And under level is com and domain. A domain is a subtree of the domain name space. The name of the domain is the name of the node at the top of the subtree. And another like this. Pager 2.39 is a hierarchy of name server. Distribution of namespace. It is very insignificant and also not reliable to have just one computer source such as a huge amount of information. Hierarchy of name server. The solution to this problem is to distribute the information among many computer core within a server. You can see the top of root server and another level is server, and the last under level is dot. A root server is a server whose zone consists of the whole tree. A root server usually does not store any information about domain name, but delegate its authority to other server. A primary server loads all information from the disk file. The secondary server loads all information from the primary server. Picture 2.40. Picture 2.40 is a zone. The complete domain name hierarchy cannot be stored on a single server. It is divided among many servers. What a server is responsible for or has authority over is called a zone. We can define a zone as a contiguous part of the entry tree. The server makes a database called a zone file and keeps all the information for every node under that domain. Also the same thing, have a root and under row. Under level, com is zone, mhhe is domain, and the last is zone and domain. Picture 2.41 is genetic domain. DNS is a protocol that can be stored in different platforms in the internet. Genetic domain, quantity domain, and the inverse domain. The genetic domain defines which is threat most according to the genetic behavior. You can see in the picture root level and under level genetic domain. In the level 2.12 is a genetic domain label. This label describes the organization type. You can see have a label and description, and also label and description. You can read by yourself. Arrow. This description is airline and aerospace. BIS is business or film. And another like on the picture. Picture 2.42 is a country domain. To shorter country abbreviation USTHKR and another. Second level can be organization, nation, national designation, like this picture. University of California, Uven University in the state of California in the United States. In picture 2.43 is a recursive resolution. Mapping a name to an address is called name address resolution. DNS is designed as a client-server application. A host that needs to map call a DNS client call a resolver. The resolver access to hosts DNS server with a mapping request. A resolution can be either recursive or iterative. You can see the root server and how to step by step. Source is some.nn.com. Destination is engineering mcgraw.com. In picture 2.44 is iterative resolution. Reduction of this search time would increase efficiency. DNS handle this with machine call caching. The server marked the response as unauthoritative. If a server tries a mapping for a long time, it may send an outdated mapping. The authoritative server always adds information to the mapping called time to level TTL. And this is how step to step. Also the same source and destination. For a table DNS type 2.13, a resource record in a 5-tuple structure. Domain name type cross TTL value cross type of network IN internet. Type how to value should be interpreted. Have a type and interpretation of value, such as a 32-bit IPv4 address C in chapter 3. NS is identify the authoritative server for zone. Picture 2.45 is DNS message. To receive information about host, DNS use two types of message: query and response, same format. The above is a header, identification flag, question section. Note: the query message contains only the question section. The response message includes the message section, the answer section, and possible to auto section. Example of DNS message. Example 2.14. You can see web link. You can see name and address. In UNIX and Windows, the NS lookup utility can be used to retrieve address slash name mapping. The following show how we can retrieve an address when the domain name is given. For summary, applications in the internet are designed using either a client-server program or peer-to-peer program. In a client-server program, an application program called a server provides service, and another application program called a client receives service. A server program is an infinite program. A client program is finite. In a peer-to-peer program, a peer can be both a client and a server. The World Wide Web is a repository of information linked together from points all over the world. Hypertext and hypermedia documents are linked to one another touch pointer. The Hypertext Transfer Protocol (HTTP) is the main protocol used to access data on the World Wide Web. Electronic mail is one of the most common applications on the Internet. The email architecture consists of several components such as user agent (UA), main transfer agent (MTA), the main access agent (MAA). The protocol that implements MTA is called Simple Main Transfer Protocol (SMTP). Two protocols are used to implement MAA: Post Office Protocol version 3 (POP3) and Internet Mail Access Protocol version 4 IMAP4. The domain name system (DNS) is a client-server application that identifies each host on the Internet with a unique name. DNS organizes the namespace in a hierarchical structure to decentralize the responsibilities involved in naming. Telnet is a client-server application that allows a user to log into a remote machine, giving the user access to their remote system. So thank you for listening me.